Good day everyone, my name is Lindsay Gomez from ABPD 1C, and here's my report.
Conjunction. The conjunction of the proposition P and Q is denoted by P conjuncts Q. As we read, P and Q is defined through its truth table. So we have P and Q. So we have true, true, false, false, and for the Q is true, false, true, false. And for the P conjuncts Q, as we read, we have true and true. Our answer is true. True, false. Our answer is false. And false and true. Our answer is false. And false and false. The answer is false. So the propositions P and Q are called conjunctions. That's why the conjunctions P and Q is true only when both conjuncts P and Q are true, as shown in its truth table. Meaning to say, if T plus T in the conjunction symbol, it is always true. But if it is not the same as T, therefore, the answer is false. So, dapat laging parehong T ang ating given na statement. The hypothesis and the conclusions in the conjunctions. So, next is disjunction. The disjunction of two propositions P and Q is denoted by PVQ, or pagbasahin is P or Q. So, kanina, P conjuncts Q, and that is, pagbasahin is P and Q. So for now, and this one, PVQ, meaning to say P disjuncts Q, and it is defined through its truth table. So we have PVQ. The propositions P and Q are called disjuncts, and the above truth table shows us that the disjunction PVQ is false only when both disjuncts P and Q are false. So we have PVQ as our true statement. If the hypothesis is true and the conclusion is true, so for the PVQ or P disjuncts Q, that is true. So true, false, the conclusion still the answer is true. F, but the conclusion is true, it is true. But if both hypotheses and the conclusions are false, that's the only thing that in the disjunction it will become a false. So magiging false lang siya kung ang hypothesis at ang conclusion ay parehong false. Next is negation. Let P be a proposition. Not P is called negation of P, which simply states that it is not the case that P. So first of all, this is the simple to represent the negation, not P, negation, and it simply means it is not the case that P. If P is true, then not P is false. If P is false, then not P is true. So example, let P be a proposition. Adam and Eve lived together for many years. Then, how not P will be look like? So, it is not the case Adam and Eve lived together for many years. As I already told you that what a negation really mean when we try to negate the particular propositions that is represented by P, we simply state that it is not the case. So, or Adam and Eve haven't lived together for many years. It is not always necessary that you should place it. It is not the case. The in front of prepositions, you can write something else that goes with the meaning. Adam and Eve haven't lived together for many years. So we have P and not P. So when P is true, then not P is false. When P is false, not P is true.
Good evening, everyone. My name is Jasmine K. Banzel. Our topic for today is all about tautologies.
Tautology is referring to the truth table for the statement Q be P and Q in the previous of example. Notice that column for that statement shows only true. This means that it's never possible for a statement of the form Q be and P and Q to be false. A tautology is a statement that can't possibly be false. Through its logical structure, its syntax, the statement Q be P and Q is an example of a tautology. The example statement and tautology, we can make a truth table. Po yung tatlong table ay isang table. Meron tayong tatlong N, P, Q, R. Kaya po yan tatlo kasi yung 8 rows kasi tatlo po yung N ay P, Q, R. Kaya po naging 8 ang nagawang 8 arrows. 8 rows. Thank you po.
Hello Ma'am Norhaya Balawag. I am Ana Selwan. This is my video report on mathematics in the modern world. I hope you understand my point of view. Thank you. As we go to my topic, it's all about solution. First, the universal statement, all paddles are dogs, asserts indirectly that a certain region of the diagram must contain no element, and this is the only thing such a statement asserts. In particular, a universal statement never asserts the existence of any elements. So when we say universal statement, a mathematical statement that's supposed to be true about all members of a set. So here are some example of the diagram. Since all paddles are dogs, this region must contain no elements because of the region of this region would be a paddle who is not a dog. One of those early logics dissertation I remember was all paddles are dog but not all dogs are paddle. Next, continue marking the diagram. According to the existential statement, some dogs are predators. This means that there must be at least one element in the part of the diagram that is where dogs and predators intersect. So when we say existential, a statement that is true if there is at least one variable within the variable domain for which the statement is true, and another the meaning of intersect defines something by passing or lying across it, and also the meaning of predators is an animal that eats other animal. So here we are the example of diagram. Since some dogs are predators, there must be at least one element in the intersect of dogs and predators. Since it is not certain which of these two regions must contain E elements, we place the X of the boundary. The meaning of elements, or when we say element, an element is something basic and important. In chemistry, an element is one of the essential molecules that everything else is made of. If a book ending carries an element of surprise, it means surprise is an important part of the story end. If a region of a mark diagram contains no marks, then it is uncertain whether that region contains any elements. So here are some examples of a region mark diagram. 2.1.22 Mark the diagram according to the statement, no dogs or cats. So here are the solution. If no dogs or cats, then the part of the diagram where is to circle intersex most contain no elements. We use shading to indicate that region of the diagram must contain no elements. Here are some examples. 2.1.23 Mark the diagram according to both of these statements. All paddles are dog and some dogs are paddles. So here are some solution. If all paddles are dog and some dogs are predators, then the part of the diagram where those three circles intersect one element, we use the shading to indicate that a region of the diagram must contain one element. And my last topic is all about logical equivalent. Two statements x and y are logical equivalent if x and our y is a tautology. Another way to say this is for its assignment of truth values to the simple statements which make up x and y. The statement x and y have identical truth. Tautology means the saying of the same thing twice in different words, generally considered to be a fault of style. And example, they arrive one after one another in session. So a logic, a statement that is true by necessity or by virtue of its logical form. We have here the example of logically equivalent. Show that P, R, Q, and thus P with Q are the logically equivalent example. That's all my report, ma'am. Thank you.
Assalamualaikum everyone. I am Narhana A. Kanakan from ABPD 1C. Now, we are discussing about the truth tables. And later, I will explain what is the meaning of truth tables. Truth tables show how the truth or falsity of the compound statement depends on the truth or falsity of the simple statement from which is constructed. So we'll start by looking at the truth tables for the 5 logical connectives. And there is a types of truth tables, which is the negation, conjunction, and disconjunction. As you can see on the picture that I have an example there for the mathematical logic. Next these are example of signs and symbols or connectives. Here's the example of the negation. When we say negation, it is having a 2 column, that the statement and the not be, or the negation. When saying of this, it is the opposite. Means what is the opposite of true? It is false. So that is the example of the negation. Next is conjunction. When we say in conjunction, it is having in the middle of the statement, which is what we call and. And in the example of the column is P and Q is equivalent of true. Means if the statement are the same, the equivalent of that is that answer of that statement. But when the statement are not the same, it is equivalent of false statement. So as you can see, the truth and true is equivalent of true, while true and false is equivalent of false. Next is this conjunction. The statement here are not the same in the conjunction. Pag sa conjunction kasi, pag ang dalawang statement ay hindi magkapareho, it is equivalent of false. Pero dito sa disconjunction, pag ang statement ay may true or basta may true sa statement, dalawang statement, ay magiging true ang sagot. So, in the example of column 1 is a true or true, it is equivalent of true. The next is true or false, it is equivalent of true. At least, makikita rito or malalaman na may true ang isang statement. Next, the implication. On the column implication, you can see the two statements, the P and Q, and having in the middle, which is called implication, which is in short then. So we have a statement here. The letter P statement is if you get a flower, and the second statement for Q is then I'll give you $1. So here, let's proceed to the number 1. It is true. It is true, then true, it is equals to true, which is if you get a flower, I'll give you $1. Yes, which is true. And the next statement, if you get a flower, then I will not give you $1. So the statement is false because whatever you can get a flower, you will not be having $1. On the third, the third is if I didn't give you a flower, then I'll give you $1. Which is the statement, it is true. Whether you didn't have a flower, you can have $1 also. By in any doing something work that you will be having $1. While on the last, you can see here that the false statement that if you didn't get any flower, I'll not give you also $1, which is true because you cannot get any or earn something. The next is the word equivalent or P if and only if Q. So in that statement, you can see there the sign of the equivalent, which is in the middle of the P equivalent to Q. I have a statement here for this situation. Whether or not, and the first statement, whether or not I give you $1. And the letter Q, I haven't broken my promise, which is the statement is true. And the second is, whether or not I give you $1, but the false statement, I have broken my promise, which is the statement is false because you broke the promise when I giving you $1. It is the same on the third row that whether or not I will not give you $1, but the statement of the Q is I haven't broken my promise. Whether you didn't broken your promise, you didn't get or earn some $1. On the last statement, false the statement, whether or not I will not give you $1, and the second statement, I have broken my promise, which is the statement is true. You cannot earn $1 because you broke the promise. And that's all. Thank you.
So, ito yung report ko ngayon. So, ang tawag nito is AN, tapos ito is not P, and ito ay R, tapos ito naman is not Q. At kapag binunan natin siya, ito na yung magiging kalabasan niya. So, dito sa mga given niya is, maglalagay tayo dito ng true, so ano siya, and false, dito naman is true, false, so dito naman sa not P, true siya, so false, tapos true, false, so magiging true pa rin siya kasi pag true siya is magiging false kasi true siya. Tapos pag false naman siya, magiging true naman siya kasi parang gano'n lang siya, parang lang siya dito. So false, no, yung false so magiging false siya. And false para sila sa magiging true. So dito naman sa not Q, so dito naman siya sa not Q, true, false, so magiging false siya, true, magiging false pa rin siya, tapos false, magiging true siya, and false, nauna yung false, so magiging false siya. So paano naman siya ilagay dito sa QN and not P? So dito tayo kukuha sa mga given. Anyway, ito yung roots niya, and then dito, so false siya dito kasi kagaya ng sabi ko kanina, yung pagpareho siya din dito, pagkaiba na sila. So, dito naman, true, false. Una si true, so magiging true pa rin siya. So, dito naman, false, tapos true, so magiging false siya. And then dito naman false, false, pareho sila, false pa rin siya. Kasi kagaya ng sabi ko kanina, pag T, F, kagaya kanina. Then, paano naman siya ilagay dito sa QN and not P. So, dito naman, true, false, magiging false siya, false, and then true, true, so magiging true siya, pareho sila, F, F, so true pa rin, F, F, true pa rin. So, yun yung explanation niya. Ito na yung
Good day everyone, my name is Monina Usman Alvarado. Today I will discuss my topic, logical connection and equivalent statement. Logical connection. A logical connection is when we make a connection between two things or ideas based on similarities, parallel ideas or communities. I am not sure of the logical connection between those two statements. There is a natural and logical connection between the parks and the green belt. What are the 5 logical connections? The logical connections commonly used in mathematics are negative, conjunction, disconjunction, implication, and equivalence, which are the fancy words for things you encounter in everyday English. Next is, what are the 3 main logical? There's 3 types of logic: operators, negative, not, disjunction, or conjunction. And the next is equivalent statement. Two statements are equivalent if they always have the same logical value. A logical value is either true or false, that is, if they are both true or are both false. Next is, what are examples of equivalent logic statements? Now consider the following statements. If Ryan gets a pay raise, then he will take Allison to dinner. This means we can also say that if Ryan does not take Allison to dinner, then he did not get a pay raise in a logically equivalent. What is an example of equivalent? For example, 2 is said to be equal to 2 but equivalent to 1 plus. In simple word, we can say that two things or quantities are equal when they are exactly the same, like 1/2 is equal to 2 1/2, but 1/2 is equivalent to 2/4 as they represent the same value. And the last, what is the equivalent formula? Suppose there are 2 formulas, x and y. These formulas will be known as equivalence. If x is equal to y, is a tautology. If 2 formulas, x and y, is a tautology, then we can also write it as x is equal to y, and we can read this relation as x is equivalent to y.
Assalamualaikum, I'm Joel Tig from ABPD 1C Group 1. Our topic for today is De Morgan's Law, negation of a conjunction, and the negation of a disjunction. De Morgan's Law. De Morgan's laws describe how mathematical statements and concepts are related through their opposites. In set theory, De Morgan's law relates the intersection and union of sets through complement. In proposition logic, De Morgan's law relates conjunction and disconjunction of proposition through negation. De Morgan's laws are also applicable in computer engineering for developing logic gate. The negation of a conjunction is logically equivalent to the disjunction of the negation of the statement making up the conjunction. To negate an and statement negate each part and change the end to or. The sample is not P and Q is logically equivalent to not P or not Q. The negation of a disjunction is logically equivalent to the conjunction of the negation of the statement making up the disjunction. To negate an or statement negate each part and change the or to end. The sample is not P or Q is logically equivalent to not P and not Q.
Mathematical statements are sentences that are expressed using mathematical symbols and are used to describe mathematical concepts, operations, and relations. These statements can be either true or false and are subject to mathematical rules and constraints.
Good evening everyone, especially to you ma'am. My name is Lailani D. Santos from ABPD 1C. My topic for today is all about tautology. As a definition, a tautology is a compound proposition that is always true for all possible truth values of the proposition that will coordinate. Here is an example typology wherein all the true values are true. So, here are some important apologies that are presented. These are the laws that illustrate mythology. We have a contraposition. So, now as if P, then Q, then if and only if the negation of P, then the negation of Q, that the reduction and absurdum De Morgan's law, and modus ponens exportation, transitivity, and deduction. So now to determine whether a given statement is a tautology, you can use the table or the table of truth values or the truth tables. So, as an example, using the truth table show that modus ponens is a topology is dependence from table if P then Q, if P then Q and P then Q. So as a solution, so first we have two proposition that's P and Q. Therefore we have 4 row and P that's true, true, false, false, and Q true, false. First proposition as if P then Q, that is true, false, true, true. Next, if B then Q and P, that is true, false, false, false. And last is this modes found and that yields to true, 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 and therefore we can say that mode respondents is a tautology. That's all. Thank you, ma'am.
Hello everyone, I am Rochelle Viva Mukatilok from ABPD1C. In this video, I'm going to discuss about the using truth tables to test for logical equivalency. To determine if two statements are equivalent, make a truth table having a column for each statement. If the columns are identical, then the statements are equivalent. For example, 2.1.10, we see that P or similar to Q is equivalent to similar to P and Q. Example 2.1.12, use the result from example 2.1.10 to write a statement that is equivalent to it. Is not the case that both I won't order a taco and I will order a burrito. Solution to example 2.1.12, if P represents I will order a taco and Q represents I will order a burrito, then the statement, it is not the case that both I won't order a taco and I will order a burrito, is symbolized as similar to P and Q. The result from example 2.1.10 tell us that similar to P and Q equivalent to I will order a taco or I won't order a burrito.
Hello everyone, my name is Jermaine C. Gomez and my report is about diagramming categorical statements. Diagramming is a technique involving the use of Venn diagrams to study the relationships between multiple categorical statements. It is particularly useful in situations involving 2 or 3 categories and 2 or more categorical statements. So a Venn diagram for one categorical statement consists of 2 interlocking circles placed in a box. So hopefully now you understand what the regions or Venn diagram represents. The potentially empty intersections, differences, and complements among sets. The diagrams initially don't represent any information about the set's memberships until certain changes are made. Instead, they prepare us to organize information we could potentially get about elements of our universe of this course when we do get it. The kind of information we're interested for categorical arguments can be thought of as answers to yes or no questions. For any given region, we just want to know, is there anything there? If the answer is yes, we're going to put a small x completely inside the region. That means there at least one thing there. Meanwhile, if the answer is no, meaning the region is empty, then we shade that region. Remember that if any region of a Venn diagram is blank, that doesn't mean it's empty, but also doesn't mean that there's anything there. For blank regions, the question is there anything there has not been answered and should be treated as undetermined. Using that system, there are 8 pieces of information that we could potentially incorporate into a Venn diagram for 2 sets. It turns out some of these correspond to the traditional categorical statements.
Good day everyone and Assalamualaikum. I am Faides Abdullah and I'm going to explain what is quantified statement. What is quantified statement? Quantified statement, the word all, some, and none are example of quantified statement containing one or more of these words. Is a quantified statement. We have example here. First, example, according to your everyday experience, decide whether each statement is true or false. Number 1, all dogs are paddles. Number 2, some books have hard covers. Number 3, no U.S. president were president of Georgia. Number 4, some cats are mammals. Number 5, some cats aren't mammals. Example solution. Number 1, false, because we know that there is at least one dog that is not a paddle. Number 2, true, because we know that there is at least one book that does have a hard cover. Number 3, False, because we know that there was at last one president who was from Georgia. Number 4. True, because there is at last one cat that is a mammal. In fact, every cat is a mammal. Number 5. False, because we know that is not possible to find at last cat that is a mammal. Example above illustrate the following fundamental fact. In order for a statement of the form all A or B to be false, we must be able to demonstrate that there is at last one member of category A that is a members of category B. This is equivalent to demonstrate that is not a subset of B. This means that a statement of the form all A or B is true even in odd case where country A. Example number 4 and 5 illustrate the following fundamental fact. Although the statement some are and some aren't sound similar, they do not mean the same thing. And that's all, and thank you for watching.
Assalamualaikum warahmatullahi ta'ala wabarakatuhu. Magandang araw sa lahat. I am Johaima B. Gelal, an ABPD 1C student. So, ngayon, magsusolve ako ng some examples of negations of quantified statements. So, bago ko isolve o sagutan yung mga given examples, let me define ng mabilis muna kung ano yung negations of quantified statement. So, ang negation ay ito yung kabaliktaran o opposite ng sinasabi o gustong sabihin ng statement. Meaning, kung yung given statement ay false, then ang negation niya ay true. If ang statement naman ay true, then ang negation niya ay false. So, kagaya ng nasa box or sa dalawang column, meron tayong P at meron tayong symbol ng not and P. Yung P po ay nagre-representative or nagre-represent ng statement while yung not P, yun yung nagre-represent ng negation. So makikita natin din dito, sabi ko nga kanina, if true yung statement, then ang negation niya is false. At kung false naman yung statement, ang negation niya is true. So yun yung negation. Now, let's proceed to the given examples. So, the first example is, no used car is reliable. So, this statement is false. Mali siya. Kasi, as all we know na may mga sasakyan pa rin na kahit gamit na ay napapakinabangan pa rin. Like yung mga second hand na mga sasakyan na binibenta ay meron pa rin bumibili kahit na gamit na. Kasi yung quality ng sasakyan ay okay pa at pwede pang gamitin. So, as we negate or write this statement in negation, pwede nating sabihin na some used cars are reliable or meaning there is at least one used car that is still reliable, which is true naman talaga. So, the next example is, some acute angles are not less than 90 degrees in measure. So, this statement is false again because as all we know, acute angles are all less than 90 degrees. So, to negate or to translate it into negation, for this statement to become true, ang statement na to ay magiging all acute angles are less than 90 degrees in measure. So, the last but not the least example is the some triangles are quadrilaterals. So this statement is also a false. Kasi ang triangle ay never or hinding-hindi naging o magiging quadrilaterals. So, para gawing true itong statement, we will negate it or isasalin natin siya into negation na no triangles are quadrilaterals. So, yun yung mga examples ng statement at kung paano ito i-translate or gawing negation. So, always remember in negations of quantified statements, ang kailangan mo lang gawin is to determine whether the statements or statement is true or false. Because kapag ito ay false, then ang negation niya should be true and vice versa. Dagdag pa dito, kapag nagtra-translate ka ng statement into negation, always remember na kailangan yung negation pati statement or yung given statement ay opposite or magkaiba ng sinasabi or pinapahiwatig. Kasi nga yung negation, ito yung kumukontra sa sinasabi ng statement. So, hanggang doon lang po. Maraming salamat.
Good day everyone, I'm by Jamaica King Mama from ABPD 1C and from the group 1. So now, let's learn for my topic.
So now, I discussed the by division, a real number is irrational if it is not rational, so I could replace the if part of the contrapositive with x plus y is irrational. Example, let x and y be two real numbers such that x plus y is rational. Prove by contrapositive that if x is irrational, then x negative minus y is irrational. So assume that x and y be two real numbers such that x plus y is rational. So the contrapositive of the given statement is if x minus y is rational, then x is rational. For all real numbers x minus y, if x plus y is rational, then x minus y also be rational. So, prove that contrapositive of the given statement using the direct method. So, the sum of the two rational numbers also must be rational. So, x plus y plus x minus y, that means x plus y plus x minus y is rational by definition. So in 2x, 2 is a rational number, so x has rational. So if x is rational, then x minus y is rational. Hence, contrapositive prove that if x is irrational, then x minus 1 is irrational. So how to prove x or y is irrational? Let x and y be a real numbers. We will show that if x is rational and y is rational, then x, y is rational. Since x is rational, and x is equivalent to a and b for some integers, a and b, where b not equal to 0. So if x and y are real numbers and xy is irrational, then x is irrational or y is irrational. Xy also irrational if x and y are irrational real numbers? No. If x is equivalent to rational number and y is equivalent to irrational number, x and y is not necessarily an irrational number. It can be rational if x is equivalent to 0, which is a rational number. Proceed to the show that the inverse and the converse of a conditional are logically equivalent. So the conditional statements. In conditional statements, if P, then Q is denoted symbolically by P implies to Q. So P is the hypothesis and Q is the conclusion. So for instance, consider the two following statements.
The first is if Sally passes the exam, then she will get the job. So in these statements that Sally will get the job if a certain condition or the passing the exam is met. It says nothing about that what will happen if the condition is not met. The truth of the conclusion cannot be determined. The conditional statement is therefore considered to be vociously true or true by default. So the second is if 144 is divisible by 12 and 144 is divisible by 3. So the hypothesis is if 144 is divisible by 12 and the conclusion is 144 is divisible by 3. Example is let P implies Q be the conditional. So the inverse is negative P implies to negative Q. The converse is Q implies to P. Now, let us proceed to another, which is suppose X is real number, consider the statement. So number one example is if X squared equivalent is 4, then X is equivalent for 2. So construct the converse, the inverse, and the contrapositive. Determine the truth or falsity of the four statements, the original statements, the converse, the inverse, and the contrapositive. So the converse is if X is equivalent to 2, then X squared is equivalent to 4. So the inverse is if X squared not equal to 4, then X is not equal to 2. So the contrapositive is if X is not equals to 2, then X squared is not equal to 4. So the original statement is false. Is the negative 2 squared equals to 4, but negative 2 not equals to 2. Since the original statement is equivalent to the contrapositive must be false as well. So the converse is true, the inverse is true, logically equivalent to the converse. So the inverse is true as well. Number 2 example is if x squared is equal to 9, then x squared is equals to 3. The solution is the converse is if x equals to 3, then x squared is equals to 9. So the inverse is if x squared not equal to 9, then x is not equal to 3. So the contrapositive is if x is not equal to 3, then x squared is not equal to 9. So the original proposition is false, the converse is true, the inverse is false, the contrapositive is false. So if original proposition is true, the contrapositive is true. If original proposition is false, the contrapositive is false. So that's all my topic. I hope you learn. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I'm Joarli Dukay Abu Bakar from ABPD 1C. Conjunction. A conjunction statement formed by adding two statements with the connect and the symbol for conjunction is which can be read as and when to the statement P and Q are joined a statement. The conjunction will be expressed symbolically as P and Q. If both the combining statement as a true, then statement will be the true, otherwise it is a false. Conjunction truth table. Let us make a truth table for P and Q, i.e. P and Q. PQ for TT, TF, FT, FF. P and Q, T, F, F, F. In this table, we can say that conjunction is the truly only when both P and Q are true, if they are not Then, the conjunction statement. Rules of conjunction. The conjunction statement will only be the true if both the combining statements are otherwise false. It is similar to an AND gate which is utilized under the topic gate logic. Let P and Q be the two statements. The compound statement P and Q is called the conjunction of P and Q. The symbol that denotes the conjunction it is read as N, which is a logical connected.